Yeah, so welcome everyone. I'm Jasper from Göttingen University, and today I want to present a study on the perspective of teachers in the integrated subject science. So the combination of biology, chemistry, and physics, and their view on this, and their role, their identity in this integrated subject. And I will present some results on an interview study. Okay, so firstly, let me talk a little bit about the concept of integrated science as a subject. So this is the combination basically of what is normally in biology, chemistry, and physics, and their combination. A broad definition of such an interdisciplinary subject would be a knowledge view and curriculum approach that consciously applies methodology and language from all those disciplines to examine one question. For example, one teaching unit could have the context of pets, so little animals, and swim energy plants, using that context to teach the content, as their biology of plants, physics, of their echolocation, how they locate themselves, and then in the end, the conflict of interest between clean energy and conservation of nature. That would be one example, combining biology and physics. We can think of more broader topics. This is just one example. And as a subject, combining those in middle and high school, there can be multiple arguments for and against such an approach. But we have to work with what we have to do in school usually. So we can say an argument for this approach is, for example, constructively connecting separated areas of knowledge. I think the opening speech today alluded to that as well. We heard today that contexts are a critical, important point of teaching. So, and hence context strategies show big effect size, and they are usually one big part of such an integrated approach. And also, one could say that if we have a more broad view of questions in for our teaching units, that it improves the tolerance for ambiguity in our answers. There's no one clear answer. When we think of the bats and the wind energy, well, you have to balance out certain ideas. How does it look in Germany, where this study is based? Well, we have a long and varied history and debate over either separating those disciplines or putting them together with no clear answer. As you can see, the different federal states do different things. But in this study, we will focus on the integrated approach as it occurs in one particular type of middle or high school in the grades 5 to 10, so roughly students aged 10 to 16. Yeah, the specific implementation of this subject may vary by school. So some schools do it a little bit differently than others. That's why I would gave one broad example of this approach. If we look at the subject integrated science from the teaching perspective, we can see, well, as opposed to the traditional approach where separated subjects like biology, chemistry, and physics, starting in grade 5, were taught by different teachers, so up to 3 different teachers for the discipline or subject. And in the integrated approach, there's only 1 teacher at a time responsible for all 3 disciplines. And we're looking at schools where this is the case for grades 5 to 10. This, as some background, the teacher education system in Germany has the students study 2 subjects in university, and in the state-organized teacher training preparatory service that's coming afterwards. So they have 2 subjects, and in the case of teachers who are in science, it's at least 1 science, but it can be combined with anything. So teachers are specialists, one could say, for 2 subjects. Well, this brings us to a certain problem when we look at an integrated subject science, which combining the 3 disciplines. We could say, well, the teachers are really hardly out of field, with just the working definition for out of fieldness being that they are not expert for all 3 disciplines. The typical science teacher usually has 2 out of field areas. This is very particular if you think about this way, that they are educated for 5 plus almost 2 years, so they have very long education, and they still end up being non-specialists in maybe 2/3 of their teaching. As opposed to, for example, mathematics, where there's also a lot of out-of-field teaching internationally. In science, it's a little bit different because they're not out of field completely. It's not binary in the sense that they're either teachers for math or not, but they're really teachers, say, for biology, but then they're in science, so they're partly out of field. One could say that this integrated teaching leads to multiple challenges for teachers. I mean, this is kind of obvious. They didn't study and learn about, for example, 2/3 of this subject. So it leads to multiple challenges. And yeah, how often does this occur? We don't really know, but we have some nationwide data that roughly 30% of science teachers experience out-of-field teaching at least once per year, so in one class that they teach. Yeah. Now looking at teacher identity, we heard in the first talk of this session today that self-efficacy is very important, and this kind of ties into the same road, that the identity, which can be described as the answer to the question, who am I as a teacher, is important, especially in an out-of-field situation. And the professionalism of teachers should not be reduced to their knowledge and abilities, which can be maybe measured with an exam, but that their identity strongly influences how they teach and how they perceive their situations. So that, for example, also their self-efficacy is important to understand how they deal with challenges. Yeah, to wrap up, in the subject integrated natural science, we maybe could think about 2 different ways this could work out. So someone who remains a one discipline specialist teacher, saying I'm a biology teacher, and seeing everything through that lens, or someone who's maybe more multidisciplinary, integrated science teachers who thinks, well, I'm going to teach science first and foremost. Which leads me to the research interests. First of all, describing the phenomenon of out-of-field teaching in that subject integrated natural sciences. And more specifically, how do teachers describe themselves? Do they see themselves more as science teachers or as specialists for one of the disciplines? And the focus here is first and foremost generating hypotheses for future work, maybe. And just to put this in perspective, maybe in an educational sense where we are more so focus of the study is the personal context and the teaching practice of teachers. So we're not really going to talk about policy or something like that. And we're looking at the phenomenon more on the micro level, on the level of teachers, as opposed to let's say the national level of learning outcomes of the entire nation or something like that. And we're looking a little bit at school support for means of that. For the methods, we conducted semi-structured guided interviews, a video conference, and some biographical data on their professional life, and applied qualitative content analysis, inductive categories. And one might ask, yeah, why no observations? I mean, that would be maybe obvious to look at what the teachers do in a classroom, but a couple of constraints, for example, that the instructional quality of teaching is not stable. So if we want to look at something that is more broadly, like the approach to science as a whole, we would probably need a lot of lessons to get an idea of how this particular teacher approaches that question. And also the congruity theory saying, well, the beliefs that the teachers might tell you in an interview situation more or less are congruent or corresponds with the action in the classroom, so you get a faster track at their actual beliefs. And then on a practical level, teachers and administrations are likely relatively hesitant to researchers coming in for a lot of time and looking at the school situation. So what's the material we're working with? We conducted 15 interviews, roughly half an hour. Most of the teachers, teachers will teacher education consisting of university studies and teacher training afterwards. The surface features, age, gender, working experience seems reasonably balanced. For example, working experience, we have newly hired teachers up to department heads and different former school types. Currently, all teach in school type that has integrated science, of course, but some of them were in classical high schools before that, for example, so they can even maybe contrast the situation a little bit. For the natural science subjects, we had a relatively balanced distribution. Maybe chemistry is slightly underrepresented, but I think that's okay in general. And this is the interview guide we use. We had some main questions. It's an open interview guide, so it's supposed to have the teachers tell their story. So we open with something broad, like how did you become a teacher for the subject science, and then they usually start talking about their way. Maybe something we heard today. It's important what kind of science-related project they did as a child. that could come up in such a situation. So they got there. And then the questions 2 to 4 are more about their actual practices in the integrated science subject. And then with the 5th question, we go more to the aspect that they're partly out of field and how they feel about that. And then maybe most important for today is the question, how would you describe your self-image? You see yourself as a science teacher, and then to wrap it up, just we ask them how they evaluate the concept of integrated science as a whole. Yeah, so we did word by word transcription of the interview and had it automatically transcribed and applied an annotation, and in the end we get a video with subtitles that you can work with further. To the results. What kind of challenges did teachers report? Most cases stress that they were not adequately prepared to teach integrated science, which is not a surprise, I guess. And for example, they turn to school books and their own faculty for help. This is, I guess, not surprising either. What is good, I guess, is that whenever the faculty seems very supportive of their situation, for example, specialists for chemistry showing experiments to non-specialists, this seemed to help the teachers a lot. So working within their own school seems to be a good way to deal with the challenges. So teachers who feel supported seem more happy with this challenging situation, whereas those who are kind of fighting on their own, even feel that they're kind of stuck in some kind of dilemma. What teachers alluded to as well was when the first thing that they miss is content knowledge about the disciplines they don't study, they didn't study themselves. But once they attain that content knowledge somehow, then they start mentioning, well, I don't really know how to teach that content to my students. So it's kind of a ladder process. You need the content knowledge, and then it becomes apparent that you don't really know how to teach it. This slide and slide 4 is pretty much in accordance with former research from other countries. Now to the results. Science teacher versus specialist. So the extent to which teachers embrace the idea of an integrated approach and see themselves as kind of science teachers is a central dimension to this whole phenomenon. So some might say, well, I'm a science teacher, or in my role right now, I see myself as such. Others openly say, well, I'm still a biology teacher, for example, or I don't identify as a science teacher, they're still specialists. Then we can see, well, is this set in stone, or is there maybe potential to develop over time? Some teachers see it as a goal for themselves to develop actively their identity towards the science teacher identity. Someone, for example, said, well, I'm still a science teacher in training, despite having a degree, and that's how he would assess his situation right now, but he sees to develop this clinical aspect, or someone who says, well, I would still consider myself first and foremost as a chemistry teacher, but there's an openness. And then one other aspect is the situational versus stable aspect. Some teachers actively change their role depending on the situation and the perceived expectations brought to them. For example, by students and parents. So one says, well, if I were to introduce myself for grade 5 to 10, well then I'm a science teacher. But beyond that, I would present myself as a specialist, for example, for chemistry. Or yeah, this is pretty much the same. It depends on the school, and the person says he would set it that way for him. So he acknowledges that he's kind of in a situation where he has to play a role to fulfill the expectations. Yeah, then there are some cases that still see themselves as physicists in this sense, so as scientists, not even they're not even seeing themselves as teachers first and foremost of the science, but as a specialist for the science. And some see themselves as teachers first and foremost. So they don't think about it as so much as a science class, as a class of humans, and maybe they have pedagogical aspects to work on first and foremost. Well, to summarize, we saw that some are happy despite the challenge with the situation, and some are more feeling stuck in the situation. In their role as teachers, some see a potential to develop, whereas others are stable. And some see their role as science teachers more situational or static. And towards the question, science teachers versus specialists for one of the disciplines, we saw that both options, one could say, are present. But ideally, teachers embrace both. I mean, you can be a perfect specialist and still embrace science when you're teaching it. It doesn't have to be a one-way street in that sense. And this leads to being a reflective practitioner. So to wrap it up, what did we do at the University of Göttingen? We introduced an additional certificate teaching integrated natural sciences, because most of our students, well, that's the but most of them said they were not prepared for integrated natural sciences. And in this additional certificate, we have the students take the pillars that they don't have in their regular studies, and then have one module looking at integrating teaching, instruction ideas. And over the last couple of years, we had roughly 20% of students complete this certificate, which I think is a good value for a program that is additional to their normal studies, mostly on top of what they usually do. That is one way to answer a lot of the question raised with these teaching out of field element that we can address at the university. I guess other things are more on the political level decided. Yeah. With this, thank you for your attention.